The first section just says use identities to find the value of each expression. They give you two things that they want you to find. In this case, they want you to find cosine and cotangent. And then they give you two other pieces of information. They told you what the sine is. They also told you that the cotangent is positive. Now, if you use these two, it's going to basically tell you what quadrant you're in. So if I were to look at this, I would say, well, it has given me a sign that is negative. So that narrows it down to two quadrants. I know that sine is negative here and sine is negative here. And then it tells me cotangent, which is cosine over sine, is positive, which means that if my sine is negative, the only way I can have a positive cotangent is to also have a cosine that is negative. So it's going to put me in the third quadrant. So I know that I'm in the third quadrant just from the information they gave me. Then it says use identities. They gave me sine and they want me to find cosine. So I am going to use my Pythagorean identity that says sine squared plus cosine squared equals 1. And I'm just going to plug it in. My sine is negative 1/2 squared. I don't know my cosine. I'm going to just solve it 1/4. Subtract it. And then take the square root. Remember, square root is positive and negative root. However, I've already determined I'm in the third quadrant. So I already know that I am going to say that the cosine of theta is going to be the negative root of this, which is negative square root of 3/2. All right. They also want the cotangent, which is just, I mean, once you have sine and cosine, you have everything else. Cotangent is just cosine over sine, which means my cotangent is just the positive square root of 3. So basically you're using two things here. You're using which correspond to each other based on the 90-degree flip, and then whether or not the positive and negative makes a difference in what you're solving for. And so when you look at these, you're basically just going to say, well, I know that the cosine of pi over 2 minus theta, I can replace that with what? Yeah, I can replace that with the sine of theta. So I know the sine of theta equals this guy right here. I want the sine of negative theta. And this is another identity that tells me the sine of negative theta is just pulling the negative on the outside, doing the sine of theta. Well, I actually already know what the sine of theta is, so I can just fill that in. If they want the sine then of negative theta, that's just like saying the negative sine of theta, which is negative 0.82, which negative and negative gives me a positive 0.82. So when it says simplify, and then I put a little caveat, there should be no fractions left in your answer, that's because I'm letting you know you should work until you have trig functions with no fractions. All right? And so if I were to look at this cosecant squared, cosecant squared, cosine squared, whatever, then it's wanting me to simplify this more than what it already is. And so if I were doing this, I would probably write everything as sine and cosine. Cosine is already written and sine or cosine, so I could leave him alone. Cosecant is what? 1 over what? My sines? Yep, so cosecant squared would be 1 over my sine squared. If I were to simplify that, I would say, well, then that's cosine squared over sine squared, which is just cotangent squared. So these are going to be an easier ones to do, but they definitely don't want you to leave it with fractions. I just pulled the next one. Secant squared minus 1. Secant squared minus 1. Secant squared minus 1 is from a Pythagorean identity. Remember, if you have tangent squared plus 1, that equals secant squared. So secant squared minus 1 is going to equal what? Tangent squared. No, secant squared. So I have tangent squared over sine squared right? And then I can rewrite this guy. I would rewrite my tangent as like a sine over cosine. So I have sine squared of x over cosine squared of x divided by sine squared of x. If I were to flip that particular guy, then I'm going to get times 1 over, right? Flip, I would say that's going to be keep my sine squared over my cosine squared, multiply that not by sine, but by 1 over sine, right? And then I'm going to get 1 over cosine squared. And I can rewrite that how? What's 1 over cosine squared? Verify is going to look like this, and it is going to, you can do it multiple ways as long as you get them to look like each other. You can simplify one side over the other. It really doesn't matter. On this one, I'm trying to get cotangent squared minus tangent squared to look like that left side, or I'm going to try to get the cosecant squared minus secant squared to look like the right side. It really doesn't matter which one you deal with. Either way, you're going to end up with the same thing. So if I were doing this one, I would probably do the left side, just because the cosecant squared is going to correspond to my cotangent squared. So is my secant squared, but I'm going to end up with exactly what I need if I do it. It's only going to take a couple of steps. So if I were doing this, I would probably rewrite this guy. Cosecant squared, that is the same thing as cotangent squared plus 1, right? If I were using my Pythagorean identity. So I can just replace this guy with cotangent squared of x plus 1. And I have minus secant squared of x. And then this 1 minus secant squared of x should actually look familiar, because if I have tangent squared of x plus 1 equals secant squared, then 1 minus secant squared of x is going to equal negative tangent squared. And so I can actually replace this guy with a negative tangent squared. So I have cotangent squared of x minus tangent squared of x. And I'm actually done there. Great. So, but you could have done the other side and change the cotangent squared to the cosecant squared, etc., and gone from there. All right, cotangent squared on top, cotangent squared plus 1 on bottom, and I want it to be cosecant squared. I would actually deal with the Pythagorean piece first of it. So obviously this is a Pythagorean identity, right? Cotangent squared. So I'm going to leave the top alone. Cotangent squared plus 1 is cosecant squared. And then I would do everything in sine cosine at this point and see if I can simplify it to cosine, because clearly I'm moving towards a cosine. So I'm going to rewrite this guy. Cotangent squared is cosine squared over sine squared. Cosecant squared is 1 over sine squared. This simplifies, right? Anytime you have a fraction over a fraction with the same denominators, it's numerator over numerator, which simplifies to just cosine squared of x, which is where I was going and where I wanted to be. All right, I do want to point out the domain of this is from 0 to 2 pi, inclusive of 0, not inclusive of 2 pi. Because 0 and 2 pi are the same thing. So what I'm telling you is if your answer gives you 0, give me 0, not 2 pi, if that makes sense, okay? If you have something like this where you have the same exact trig function, your goal is to get all of those to one side. If you have multiple things going on, which I think I chose one of those, then you're going to probably do some factoring or something like that to get it equal to 0. But when you have it just one trig function, which is really what we have, secant squared, you want all those on one side, all your numbers on the other, and then solve. When we move to a little bit more difficult ones, you may have to do some factoring, all right? So this one's fairly simple. I am going to just move this 3 secant squared rather of theta over. Right, -2 and +3, I just get that secant squared. And on the right-hand side, I just have a 1. I am going to take the square root of both sides, right? Remember with square roots, it is the positive or negative root, so that means it can equal positive or -1. Secant is my reciprocal of cosine, right? And the reciprocal of 1 is just 1. So really I'm looking for where my cosine is either 1 or -1, right? Reciprocal of secant is cosine. And so I would look on my unit circle and I would say, well, I have 2 places where I get a 1 or a -1. That is here at 0, right? My, this is actually 1, 0, and this is 0 and 2 pi. And then over here at pi, I get -1, 0. Right? And so those are the 2 places that's going to happen on an entire circle. So my theta is going to give me either 0 or pi here. So when you're doing one like this, don't let it throw you that you have all of this going on. Likely when you have 2 trig functions, if you cannot do some replacement, like with Pythagorean identity, then you're just going to move them all over, 0 out this side, simplify this, and then see if you can factor. Factor it out, set each factor equal to 0, and then find on the unit circle where that happens. Where does that happen on the unit circle? Those will be your answers.